when you found out that you got in? How did you feel? What was that like?
Yeah, no, it was wild. Like a lot of us, high school got kind of messed up with COVID, and so that was my senior year of high school in boarding school. Left for spring break, found out we weren't coming back 2020, but I happened to be in vacation, luckily in Japan with my family, enjoying it, and that's actually when my MIT acceptance letter came out. So it was like 4 a.m. in Japan.
Mhm.
My mom woke me up. She's like, "I think the MIT letter is out." So I checked it, and I think it was just a surreal shock experience. I mean, like I don't remember this, but my mom tells me like I pointed to MIT in a college prep book. She was a substitute teacher growing up earlier in my life, and I pointed to MIT in a college prep book when I was 5 and said, "I'm going there." And
Um,
so it was like kind of a surreal moment for her and for me at the time. Had been said I was wanted to go to MIT for the longest time.
Welcome to Cameron's Lab Dive In, the podcast that opens doors to the world of STEM for students everywhere. I'm your host, Cameron Young, and I'm a biomedical engineering graduate with honors who is currently studying a master's in AI and machine learning. I have been captivated by science and technology ever since my grandpa, the late Kenyatta Young, gave me my first screwdriver at 3 years old. But I didn't always get the chance to connect with the experts shaping those fields. Now, I'm here to give you what I wish I had: access. Each episode, we'll meet industry leaders, attend international conferences, and uncover future innovations. Let's dive in and see where curiosity can lead.
Hi, everyone. Welcome back to Cameron's Lab. I am being joined by Kairo Morton. Very excited to have him here today. I know I say that for every guest, but every guest is pretty exciting for me. So Kairo is especially exciting because we actually went to preschool together. We are both from Bermuda, and I'm just really happy to bring him to you today because I wanted to show, especially Bermudian students, a bit more of what we can achieve. Because I feel like when you grow up in Bermuda, you get two set paths: business, accounting, that kind of side of everything. But Cairo kind of veered off of that path and he's looking at AI, technology, building the future, really. He recently graduated from MIT with a bachelor's degree in artificial intelligence and decision making. During his studies, he completed 2 research internships at Google, where he developed AI models for web page translation and video understanding. He also conducted 3D computer vision research with the MIT Scene Representation Group, and these research experiences led Cairo to his current position as a research scientist at a 3D generative AI startup in San Francisco, Stealth AI. He'll be talking more about that later. And outside of work, he enjoys rock climbing, volleyball, and just little things that help him to stay balanced and keep creative. So, Cairo, thank you so much for joining me. I am really excited to have you here.
Yeah, thank you so much for having me. I appreciate it.
So what I wanted to get into was, I guess if we could go back to the beginning. So like I said, in Bermuda, you have like a few paths that you really get told about and really inspired to go on. So what
Yeah.
sparked your interest in AI? Was it like science fiction movies like the rest of us, like a bit of Star Wars or something? Like what sparked that interest for you?
Yeah, I think I was fortunate enough to be able to go to Somersfield Academy in Bermuda. It's a private school. I started there when I was 9, so fourth grade, P5. And my first year there, I was able to do robotics, and I was doing robotics while I was there. So started with Lego robotics. It's actually when I first started programming. Um, and I think from there, I just kind of fell in love with coding. And it kind of picked up from there. I was doing a lot of own self-study after that. So on the robotics team at Somersfield, while also teaching myself, like JavaScript, C Sharp, HTML, like that's kind of where I started. Um, and I think from there, I kind of knew that like I didn't want to go down the normal route of reinsurance. Like that wasn't really interesting to me. I was like, I'm going to do the software engineering thing. I don't know if I can do it here. I probably have to, go off the island. But at that time, I didn't really know I wanted to get into AI yet. It was more robotics programming. And then I would say somewhere around like, well, I should say, let me back up a little bit. I again was able to leave the island for my second year of high school. So from my sophomore year of high school to my senior year of high school, I went to boarding school, like an hour outside of Philadelphia. And that was a good experience. Got to continue doing robotics. And I think while I was there, I kind of, right before and like kind of when I first got there, I realized I was really interested in AI. Big AI boom started maybe 2012. This was like 2016, 2017 time. And so still like, kind of early on learning all this stuff. ChatGPT is, far down ahead on the curve there. And so started picking up some stuff, learning what I could, online videos, those type of things. But it wasn't really until maybe midway through my junior year, I came home actually to Bermuda for a conference, a hackathon, Code 411, put on by Jade Eve. He was hosting these yearly hackathons, and I had met a researcher from Yale at the time. He was a PhD student who had actually been in Bermuda on vacation and decided to volunteer at the hackathon. He taught a class. He worked on actually like code generation stuff, like using traditional methods. It wasn't AI at the time. It was like, traditional formal methods for like searching the space of possible programs that satisfy like some specification of some code, what behavior you want the code to have. And so I kind of started off doing a little project for his lab, and then eventually we came together and put together a research project that I ended up doing over the summer, which incorporated basically AI into that formal process or that classical process. It was a mix of like AI and classical methods to do program generation. Like, again, this is, before ChatGPT and these things, before we knew you could generate code with like AI models completely. And that was a really good experience. Ended up publishing a paper from there. And I think it was just like on to research from there. So that was like AI interest and then into research. But I think I always knew I wanted to do like science, and then it just kind of built from there.
Well, I think what I'm starting to hear a little bit more in your journey is a lot of like networking and kind of like meeting the right people at the right time, which is definitely something I think that students should try to do. Like, I feel like it happens if you're in the right spots. So how would you, I guess, recommend for students? Like, what advice would you give for them to really meet the right people, and then how to build on those opportunities when you do meet them?
Yeah, for sure. I think, I think people, see success and like think, oh, this person must have like done some crazy thing, or like, but really, I think it's a combination of like preparation and the luck that happens at the same time. Like when the opportunity presents itself, you want to be ready so that you're there to take it. Like if I didn't have the programming background, I wouldn't have been able to like start that research project. So like the self-study I did built the skill set I needed to do that, but it also happened to be right place, right time. And so I'd say keep putting yourself in the environments that you think will most able you to succeed, to the best of your ability. Like I said, I was fortunate in a lot of ways to be in some of these environments, but like do as much as you can in your power to put yourself in the right spaces where you're going to meet people. And then you never know who you're going to meet. So just keep preparing yourself outside of that, so that when you do end up meeting that person or getting in that environment, you're ready to take that opportunity and use it to propel yourself to wherever you want to go. So I think that's kind of the combination of the two.
And that's great. And then I also liked how you were talking about when you were in Somersfield, that's when they really started introducing robotics, and it kind of sparked that interest for you. So I think one of the projects I saw that you had mentioned was about Burmese. That was back in the day. I
Yeah.
know I'm taking it way back. But could you talk a
Yeah.
little bit about like the significance of really giving back and then sharing that knowledge with the community, especially in fields like AI and robotics?
Yeah, for sure. So Bermuda was a project that me and two of my classmates at Somersfield did in M3, so eighth grade. And that was we started a robotics program. We had all done some robotics at some level at Somersfield, and we wanted to give that back to the island more broadly. The main mission there was to bridge kind of the gap we had seen between public and private school education in a lot of ways. And so we wanted to provide some of those resources to the wider community. We started at my elementary school, West Pembroke Primary, and we did a robotics program there after school for a select group of fourth and fifth graders. It was a really good time. We did it 2 years in a row, ran a camp as well, raised money to fund getting basically Lego robotics kits for pairs of two for all the students. And then we participated in a competition with them, a local island competition with them. It was a good time, learned a lot. But yeah, no, I think it's really important to give back, especially like I said, I was fortunate to get some of these opportunities just because of my positionality in that sense. But not everyone has that opportunity, and so I wanted to provide that to as many people. I haven't seen some of those kids in a while, but I would hope that that experience sparks some of them to go and be interested in robotics technology. I just like you said, in Bermuda, we kind of get these fixed set of pathways you can go down, and everyone's kind of doing this same thing. So the more opportunities we can provide, the more representation we can show that, like, hey, I was in your position, a couple years ago, and now I'm here. That really helps people to see, where they could possibly be. So.
Yeah, definitely. 100%. I remember those little Lego robotics kits. I think we
Yeah,
got a
yeah,
few when I was I did a camp. I loved those. They were so cool.
yeah, yeah, yeah. I agree.
Just going on now, I guess to continue off of that experience of giving back to the community, that's something that I hope to do as well with the podcast by introducing people and the students especially to other students like yourself to show that it is possible. Like, there's more off the rock, I could say, and more
Yeah, yeah.
different opportunities and things that are out there for you. So I do want to pivot a little bit and start talking
Mhm.
about MIT because I
Yeah.
feel like that is okay. It's not a feeling; it's the truth. MIT is like this huge name. Everybody wants to know more about it, and once you're in there, it's like you're that guy, really. Like everybody knows your name. They want to know how you got there. So, what was that like for you when you got that acceptance letter? Like when you found out that you got in, how did you feel? What was that like?
Yeah, no, it was wild. So, like a lot of us, high school got kind of messed up with COVID, and so that was my senior year of high school in boarding school. Left for spring break, found out we weren't coming back 2020, but I happened to be in vacation, luckily in Japan with my family, enjoying it, and that's actually when my MIT acceptance letter came out. So it was like 4 a.m. in Japan.
Mhm.
My mom woke me up. She's like, "I think the MIT letter is out." So I checked it, and I think it was just a surreal shock experience. I mean, like I don't remember this, but my mom tells me like I pointed to MIT in a college prep book. She was a substitute teacher growing up earlier in my life, and I pointed to MIT in a college prep book when I was 5 and said I'm going there. And
Um,
so it was like kind of a surreal moment for her and for me. At the time, had said I was wanted to go to MIT for the longest time. Yeah, and so that was a crazy moment being in Japan and like having that experience. I'd also wanted to go to Japan for a good portion of my life, and so like both of those things together was really surreal. I think it was, and I know probably other people experience a bit of this too, but like there's definitely like an imposter syndrome when you first like find that out. When you get there, you have this feeling of like, should I be here? Like there's all these smart people, like you have this adjustment to make, and I feel like that's like multiple stages of my life where like people talk about it, but you don't really feel it. Where you go from being someone who like you look, I mean, maybe not you're looking at yourself like this, but you notice in your classes, you're like maybe one of the top people in your class, you're noticing these things, and then you get into a new environment and everyone's like that. And, you have to step it
mhm.
up again. And so like, being open to that and, being ready to like quickly humble yourself and just get into it is this, I think, really important skill. But no, MIT was amazing experience getting that acceptance letter was super surreal. Definitely a dream of mine to go. And yeah, it was really cool.
Mhm. I think that that's amazing. I especially love that your mom was there for that moment as well. Because when
Yeah,
I got into my university, my mom was there, so like I'm
yeah,
screaming at her, she's screaming with me. It's like
yeah,
that's
yeah,
it's that great feeling. So totally relate. That's wonderful. I'm definitely jealous that you went to Japan. I'm still waiting to go. I feel like I'm a little bit closer
yeah,
now that I'm in Dubai, but we're almost there.
yeah,
We'll
yeah,
get
yeah.
we'll
Definitely
get there.
trying.
And then outside of MIT, you didn't just stop there. So I think that one of the things that you also did was looking at internships, but you went to Google for that internship, which is also
Yeah,
amazing, super cool. Could you talk a little bit about your experience? I know you did this a bit at the Link Up. I'm just going to pause.
yeah.
For the people that don't know, Kairo was also one of the speakers at the Link Up, which is the virtual conference that I recently had for girls, women, in STEM. So if you missed out on that talk, please go check it out. It's all about ethics and AI. So Kairo does talk a little bit more about his journey there, but I wanted to repeat it for those of us that are listening to this episode. So if you could talk about your experience at Google and then also what motivated you to go outside of your classes. I feel like sometimes when you're at university, it can feel overwhelming. Like you're like, I'm just trying to survive these classes that I have now. So what made you want to push yourself and go for an internship outside of that
Yeah,
as well?
so the Google thing was interesting because I had it actually started before I got to MIT. I had met, I told you about the research I did with the PhD student from Yale, um, who got me into research, and we published a paper at a conference. And so my senior year of high school in like, uh, or sorry, my senior year of high school in like January, I went to a conference in New York to basically talk about this paper I published, do a poster session. Um, be there, experience the conference. And I had gone to a career fair event, met a Google recruiter. At the time, I was 17. And so they were like, hey, you're not old enough yet, but keep in contact. When you turn 18, let me know. And so when I got to MIT, they reached out like that September, like, hey, you're probably old enough now, or you will be, come summertime for an internship in research. We can set up that process. And so, I had interviews there. So Google does like you do interviews first. Research is a little different than software engineering. So like my interviews were not as coding heavy. They were more like whiteboard math, session was the first one. So they were asking me, questions like AI math related type questions, and then looking at how I problem solved those on like a whiteboard over Zoom. And then my second interview, they were basically interviewing me about the paper I had published. They were like, asking me questions about it, making modifications to the problem, asking me how I would like update the solution to fit those modifications, those type of things, and like much more research kind of oriented than programming specific. And then afterwards you go into team matching, and so that's where I got paired up with my first research team at Google, which was doing the video understanding stuff. So we were trying to build AI models that could take video in and answer questions about them. Computer vision, video understanding type stuff. And so that's kind of how that process went. But yeah, it was also strange because I hadn't been at MIT long enough yet to be on a proper US work visa yet in the summer. You have to be at least 1 year, and I stayed home during COVID for that whole first year. And so I hadn't actually been on campus long enough. So I ended up going to Canada to do the internship because I could get a work visa there easier than I could in the US. And so I worked remotely with a team in Mountain View, California, from Canada in Toronto for that summer.
Okay, that's really cool that they were able to be flexible if you like that you could be like, hold on, guys, let me just hop over to Canada real quick, and then we can continue.
Google was great with that. Yeah, their lawyers and legal team helped set that up, so I appreciated that from them.
Wow, that's so cool.
But yeah, no, it was a good time. Worked on really cool people, really cool project there. Got another publication out of that a couple years, like a year later. They continued the project I worked on during my internship, and we published it at another computer vision conference. And so, yeah, it was cool.
That's amazing. And just for the people that don't know, could you like briefly explain in a high level, I guess, what is computer vision? Just for the people that are just kind of hearing the term a lot and not maybe understand it very well.
Yeah, so computer vision is the study of how we can get computers to see and understand the world through visual inputs. So typically, we as humans, one of our main ways of perceiving the world or understanding the world is through our sight. We have other senses too, but computer vision basically takes that paradigm and says, we have cameras and things that kind of replicate the way our eyes take in data. How can we get computers to understand that information and make decisions in the world, or do things we're interested in the world through that perception method? And so, there's many branches of computer vision, many problems in computer vision that people work on, video understanding being just one of them. People work on classification, can I take an image and determine what's inside the image? Is it a cat? Is it a dog? Is it a plane? Whatever. Image captioning, can I take an image and write a caption for it? You have image generation, which people have probably seen recently, which is, can I take something and generate an image, can I write a piece of text and generate a new image from it? And so these are like all inside of computer vision, really broad field. But it's kind of what I love to do and where I started and kind of where I'm back doing now. But yeah.
That's awesome. So I will pause and go back to the question. So if you could ask, what would you say as advice for students that want to branch out a little bit more?
Yeah. So in university, I would say the main thing is like the class, your classes are going to teach you a lot, but the real thing, at least in my experience, is like comes from building things with people where you really learn stuff. Like there's classes a lot of the time will cover theory, but like the experience you get from practically building something and like going through the process and like having to make those decisions is a big difference. So as much as you can get outside, I would say, look for things that you're interested in. Don't overcommit to stuff. Basically pick like one or two things that you think you can do really well and do those. It's better to do a few things and like do really well at them. That'll look better at like to the outside world and also help you more personally than like trying to do a little bit of everything and not really getting into depth with anything. Unless you really don't know what you want to do, and then maybe exploring is also helpful in that way. But yeah, I would say that was a big thing for me in college a little bit. I wish I did actually some more of it, got into more clubs and things at MIT, but I got into research and that happened to be the thing I stuck with. But yeah.
Lovely. So continuing with the talk about computer vision, I wanted to ask about one of the papers that you had, because I looked into it a little bit for the conference, but I didn't get to ask you, and I was really disappointed. So I want to ask you now a little bit about the paper that you had. I think it was called Video Question Answering with Iterative Video Text Code Tokenization. So first of all, what is code tokenization? And then what was the, I guess, outcome for that paper? Like, why did you want to focus on that?
Okay. Paper names, really crazy. I mean, the research was like cool. But like, note to people reading papers: if you see a paper name and the words in it look very intimidating, don't be too stressed. I mean, like, the stuff is interesting and is technical, but like the paper name sometimes is trying to condense everything from the paper into as few words as possible, and so the words get really crazy. Uh, but basically, for that paper, we were trying to solve the problem of video question answering. So, in computer vision, you're trying to test if you can build models that understand the world. And one way to do that is you have an video input or image input, and you ask the model questions about the video or image, and you see if it gives you the right answer. This is kind of the problem setup. So have some video about the world. Let's say we're watching someone play soccer or football in Bermuda, right? And you would say, you know, after this, you stop the video at some point and you say, what do you think happens next? And you get the AI to try and output, a text to like, oh, the person kicked the ball, or like the person slide tackled, or a goal was scored, whatever. So like, this is an example of what we might be trying to do. And if you think about what that problem actually entails, it's like a lot of reasoning about like what you've seen so far, priors about the world. So like things you already know about how like physics work, like if the ball is going to go in or not, you have to understand like where it's going. So there's a lot of things there that the AI model has to understand to get those. And that's why it's a good proxy for like, are we understanding the visual input correctly? Mm-hmm. And so the addition we made to the research literature there, which is a new method of like combining the information that comes in with the video and the question. So you have to process these two streams of input, the video input and the question you care about, and you have to have the AI produce some output from it. But you want to jointly process those things because really what the fundamental I guess intuition we came up with that like led to the technical advancements that I won't get too deep into, but like the intuition was basically that as humans, when I tell you to look at an image or a video and I ask you a question about it, it actually changes how you perceive what you're looking at. You focus on different things more. If I tell you to ask what's going to happen, where's the ball going to go next? Your eyes instantly focus on the ball. You're more concerned about where that is. You like forget about the people around the ball. Like, so those things change. And so we wanted to kind of give that ability to the AI model. The way in which you do that, you can basically think of it in the same way I'm saying that you kind of forget about those other things. You can kind of have the AI model from the text try and predict which things it should be looking at, and then use that to influence how it processes the image. And so that was kind of the combination of things we came up with there that led to that paper. And you said, where did it go? We published it at the European Conference for Computer Vision in 2022. I was second author on that publication with my co-authors from Google at the time, who I was working with on that team. Yeah, but it was a fun time. I didn't actually get to go to the conference in person, but yeah, it was good.
Oh, it's amazing. Congratulations. I wanted to kind of focus really quickly on what you were saying. So I feel like for the students that are listening, there were a lot of different like topics that you were bringing up. So like looking at, for example, what the AI focuses on, how it can predict things, and then also looking at how it might be able to classify different things. So for the students listening, these are all different things in AI that you could potentially be researching into, and then maybe ask Kairo more questions later. So these are things that, if you're listening to different podcasts like this, I really want to encourage you guys to listen out for the different topics that they mention, or just like little things that you might be able to find interesting and practice later. So just for the people that are listening. Yeah. I think I want to continue with computer vision because I personally find it really fascinating. I know that is your focus. I'm glad that I have you. I can continue asking you things. So you mentioned briefly that there might be some problems with computer vision as well. So I know we talked about this a little bit during the conference because we were focused on the ethics of AI. So if I could bring a little bit of that into this conversation and ask you if you could give just a few examples of what might be a possible problem with computer vision, and have you experienced anything like that yourself while you're researching?
Yeah, so generally in computer vision, and actually AI more generally, these are all problems like I really across the board. You see them in computer vision because they're easier to test, but I'll explain more about that in a second. So basically, when we train AI, we have it learn things. We have to give it some large sample of data from the world. We collect some data for our problem, or we take data from the internet. There's a lot of places you can gather data from. But at the end of the day, this is human-generated data, and in which case it encodes the same biases and challenges that we all have as people. One example would be like, if you are trying to, a good one that comes up often, and we kind of do case studies in classes on this sometimes, like if you want to build a predictor for a bank to see who gets approved for a loan. You can have people's loan applications. You can have an AI model take that information in. You can think, maybe giving the loan application to like ChatGPT or something and saying, should this person receive a loan? The problem is that the systems we built in society inherently have biases, racism, sexism, etc., that we learn about. And so the real issues you see here is that the data that you collect on who got a loan and who didn't in the past, because you want to train an AI to like do the right thing, quote unquote, and that right thing will come from humans saying, this person in the past got a loan, this person didn't get a loan. And the AI will learn patterns in that information. The problem is the patterns it learns sometimes will look at things that it shouldn't be looking at to learn those patterns. One example in the loan classification case, let's say. So typically we know that in banks, if you're white, you're more likely to get a loan than someone who's black. It's like a common thing that happens. And so what the AI might learn is that people with more, ethnic names are less likely to get loans. And so instead of looking at the actual information in the loan document, it just looks at the name and goes, oh, that's a better predictor, or it helps me predict who should get a loan. When really, the name shouldn't matter. We should be able to blank out the name and the prediction shouldn't change. And actually, this is like one of the tests you can kind of do to see if your AI is being reasonable or looking at the right things. You can kind of what we call like almost anonymize or try and remove these features that protected classes from the data and try and see if the predictions change. And so this is kind of the problems that you can have with like ethics and AI, and they come up all over the place in classification. There's a lot of like facial recognition stuff going on right now. Same issues appear, less representation of black, brown faces in data. So we're classifying those type of things. And so, yeah, we see this all over the place, different ways of trying to mitigate it. But in my work personally, it hasn't come up too often. It came up kind of in a personal project. I talked about this at the Link Up that I did in high school. I was building long story short, I was building a robotics project that was doing some facial tracking with a Nerf gun. And so I wanted to just track me and just shoot me. And I ended up messing up some of the facial recognition data such that at the end of the day, it ended up trying to shoot one of my black classmates because I had to pick between, basically either me or one of my other classmates was like the two classes I had for the classification. And I looked much more like one of my black classmates than I did my white classmate who I used as the other category. And so there's definitely ways you can set up problems such that, you run into these biases more heavily than others. But it's all about the data you collect really at the end of the day.
I think what's really important, like you were mentioning, a lot is the data. So like what kind of information you're giving it, and then making sure that it's actually finding the right connections between that. I find that really fascinating. Like, as I mentioned, I only just started my MSc for AI, but we just started learning about like the generalization of data. So if you give it, so when you think that it's correct, it's like, oh, 100% accuracy. But then you check and you give it some unseen data and it doesn't know what to do because it hasn't seen it before. So it's just like, it's interesting to see what kind of patterns and things it makes. I just find it really fascinating.
Yeah, no, for sure. And yeah, as the model get bigger and more complex, at least up until now, we see the same patterns. Like no one has really, at least in my opinion, no one has really figured out this problem of like, I give you a little bit of data about the world and you find all the general patterns that extrapolate to everyone and like work well. If you also think about it, that's like a really tall order to give to something as well. There are certain patterns we want it to find and like certain kind of things we would hope it doesn't rely on over others, but like who's to say that like one set of patterns is better than another? And so like we have to be explicit about those things if we want those things to be learned by the model. Until I guess we have better algorithms that have better I guess what we call priors, and so like what they are inherently biased to do, not in the bias in like predict black or white sort of way, but like the model what it wants to do more likely to learn one set of patterns than another basically. And so based on the type of model you pick, you can set the problem up so you have a different set of things that the model is more likely to learn. And that's kind of a lot of what we do in AI research, is trying to set up the model in ways, or the data in ways, so that the AI learns what we want it to learn and not what we don't want it to learn. All right, and so it can generalize better to more unseen data.
That is so cool. I just love AI. It's very interesting.
Yeah.
And I think one more thing I wanted to ask you about, because I know when I was growing up and getting into the robotics and everything, I was very much a hands-on person. So like, just putting it together, building it, and like, great, it works. But now that I'm getting more into this whole thing, I just graduated from biomedical engineering, and there was a lot of math. Like nobody tells you how much math is going to be in there. So if you could maybe give a little bit of insight to the students as to like what kind of things you might have seen, or like things that maybe even like a little bit of your own favorite parts that you've seen in terms of math, like anything that you really love. But
Yeah.
just warning, guys, it's a lot of math in there. Like he's talking
Yeah.
about probability, algebra, and things. Like there's a lot of math. So Cairo, I'll just let you
Yeah.
talk about that
The
a bit.
math gets heavy. Yeah, there's a lot of cool things that I've seen. I think so. From an AI standpoint, the main branches of math that you kind of get into are linear algebra, which is actually like very similar to like maybe depending on where you are in your schooling career, if you've like started doing like you know uh, like lines and like slope and intercept form and like these types of things, it's like that just like blown up a lot with some more nuances. But like at the end of the day, you're just doing multiplication and adding. And like actually, the math that neural networks and the AI we use now is built on is basically just a bunch of what we call matrix multiplication, which is just multiplies and adds between a bunch of numbers. And so that's like one heavy section. The other heavy section is calculus optimization. So calculus, and really optimization is a subpart of calculus where you're trying to say for like, how can I be the best at something? And actually, this is like my favorite part of math, or like my favorite part of calculus at least. And it was one of my favorite parts of math. One of the reasons I got into AI as well is just because like this idea that I could, have some question of like, what is the best way to do X? Or how can I like minimize the cost of this, or like maximize the amount of money this thing makes? Like the fact that I can find like the actual optimal solution to a problem, I think was a lot of the reason why I got into that. And that was like some of the cool stuff. And so like, I don't know, early on in calculus, when you can set up a problem and, you can find it such that, you have like the actual best solution and nothing can be better than the solution you set up is like super cool to me. And so like that area of math is like really heavy in AI, and the algorithms we actually use to train the AI models. When people talk about like the models are getting better and better, one is like, yes, research is happening year over year, but also like from, if I start training an AI model today, so I launch it on my computer, it will get better over, the next 2 weeks as it trained. And that's really what that is an optimization process where we're moving closer to a better and better solution. And so those are cool pieces of math that I find. So yeah, calculus and linear algebra are like kind of the foundations, and you have your probability and statistics that come up a lot as well. And so I think those three branches together make up like the really foundation of AI.
I love it, and I think I learned a little bit more about your love for like finding out problem solving. With I was doing a little bit of little internet looking, and I saw that you had this article on Medium about a game that was like shut the box, and you were looking at like the probability, and you were trying to optimize it. So that's I also wanted to talk about that a little bit as well. Like, do you still do that? Do you still look into games and try to see how you can find the math behind it? Is that still a hobby?
A fun problem. Yeah, so it was like it was actually really funny. I was coming back from visiting my girlfriend who was at Brown while I was at MIT. I was coming back on the train to Boston, and I was actually scrolling like Instagram Reels or Shorts or something, and I saw this game. I was like, "What is this game?" Basically, it's a game where like there's these tiles. There's like 9 tiles, like dominoes almost, but they have like numbers, like numbered 1 through 9, and they start like all up, and you roll a dice, and then basically you can you flip down any tiles that sum up to what the dice roll was. So if you roll a 6, you can flip down like 4 and 2, for example, or 5 and 1, and you decide which ones you flip down. And basically the goal is to keep rolling the dice until either like you flip down so many that nothing sums to what you did, and then you lose, or that you can shut the whole box so you get it, so you flip down all the tiles. And I was watching this game and I was like, there's got to be something here like math. Like, I'm curious, how hard is this game to win? Like, I saw these people playing it and they seem to like win it like like in a couple tries or whatever. And I was like, this game looks really hard to win. Like, something about the math here seems weird. And so like, I just like went home and spent some time writing out the math for it. A couple tricks from some probability classes and some other things there. And yeah, you figure out it's like pretty unlikely to win. It's like a couple percent chance of winning it, which is fun. It was a fun side project. I decided to write it up for a blog post. Thought it'd be interesting. Ended up getting it, on Medium, which was nice, or towards data science, which is like Medium's like data science AI kind of publication math. And so that was fun. A little fun side project. I haven't done it since then, but it was just something. But kind of one of those like things in my kind of nerd out about for a little bit, and then go away. At my company, we actually have a word for it. We call it getting nerd sniped. So if there's a problem that like it happened at work where like someone will walk in and be like, "Hey, this is the problem we're working on," and like even if it's not your problem to be working on, you'll hear it and your brain will start thinking about it, and then like now you've been nerd sniped. Like you're gonna get sucked into the problem. And so yeah, it's one of those things that happened to me. But yeah, it was fun. I enjoyed.
I just think it's funny. So just like the little things that catch your attention, that's how you know that you're meant to be in like the research data science kind of area. When you start obsessing behind the math and things, that's kind of the
Right.
sign. That's how you know. So speaking of your current role, so you're now working as an AI research assistant at Stealth AI in Silicon Valley.
Yeah, very
If you could
good.
talk
Yeah,
about
I am. So
what the company is and then what it's like working in Silicon Valley as well.
yeah, so sorry. I work at it is a stealth AI startup, but really what that means in Silicon Valley is that we're not like openly out in the public like with a product and those type of things. And so when people say like someone says, I work at a stealth startup or my startup's still in stealth, it really means that like people don't know who's funding you yet, like these types of things. And so really the company I work is called Backflip AI. We do 3D generative AI work. We build basically the future of taking anything and fastest way to create a 3D object. And so you can think, people in movies, games, they need 3D assets for their things in the same way that you can, generate an image and you can use that for or a video and use that for a movie. We want to be the same thing, but for 3D. In both the games kind of video space and also the mechanical space for like mechanical engineers and people. So the fastest way to go from nothing to a 3D part that can exist in the world or not can exist digitally. And so that's kind of what I work on. I build AI models for that. Can't get too much into the details there, but that's like generally what I do there.
Huh, that's so cool. I didn't realize that there was like
Yeah.
a kind of like a code word. I thought that was the real name.
Yeah. Name the company. Yeah. No, for
Cool.
sure.
So I guess how did you transition from being a student researcher? So for those of you that don't know, Kairo's actually just graduated from his bachelor, so doesn't have like the master's
Yeah.
or anything, which what you would initially expect from somebody that's already working in a startup somewhere. So could you talk a little bit more about how you went from graduating from your bachelor's to now working in a startup?
Yeah, and so yeah, for me, it was one of those things where I was actually a decision I was kind of struggling with throughout my bachelor's degree of whether to do grad school, PhD, master's, what the situation was there, and I realized that I had been lucky enough and kind of built the skill set up enough to do research. I had done the research internships. I was doing research at MIT. I wouldn't say I like have the same level of research skills like a final year PhD student, but I knew I could do it at least to some decent level. I had been around PhD students, worked with them, worked with people in industry. And so I thought, I could do a PhD, but I could also go to a company and do research. I have the background for it. And so really what it was is just like me trusting in my own ability. And one thing I like about computer science in a lot of ways and the interview process typically for computer science is that like a lot of people don't care as much about degrees. Mind you, there's still people who are like, to do this research role, you need a PhD. But at the end of the day, if you can pass the interviews and you're like technically capable, and people don't really mind the degree as much, especially at a startup. And so like for the startup I'm at, for example, it was a like 5 or 6 round interview process, pretty much all technical. And so, I gave a research presentation. I had multiple coding interviews. I had research talk interviews where I had to like sit down with one of the researchers on the team and like discuss ideas. And they're getting a feel for like how I think through problems. Like I said, mentioned for the Google interviews as well. And so, yeah, not typical path, but one of those things that I realized I had built up the experience and was able to do. And I still say now that like a PhD is not off the table. I think it's just one of those things where if I find a problem that I don't think I could study in industry, because at the end of the day, there are kind of different sets of problems. When you're at a company, they're looking for you to solve the problems they have for their product, which right now is super interesting for me, and I love like the problems I get to solve at work every day. But if you want to do your own guided research, like based on your own, only on your own interest, you can work on like really theoretical things that like don't have immediate like monetary impact. A PhD would be like the right place to do that. So if I ever find the need to work on problems like that, and there are a couple of problems that I like that are like that, then that's when I would go to grad school or do a PhD.
I was enjoying listening to you about your path, and it sounds a little bit similar to my own in the way that sometimes what you want isn't necessarily there, so you can build your own path, which is what I really like about the STEM field. Is that it's very, I wouldn't say flexible, but at least like if you have the skills, if you have the knowledge, you can build your own path, which is what I really appreciated about learning about your path so far. It's like you really seem to be building your own path, which is really fascinating. And I hope more Bermudian students take that advice that you can build your own path. You don't have to stay in the one set one that we all kind of learn about.
For
So
sure.
what advice would you give to Bermudian students that might be, back where you started? If you imagine like before you met that robotics group, or maybe even just before it started, what would you say to the younger version of yourself to kind of help you get along a similar path?
Yeah, I mean, stick with your passions. That's like the main. I think that's the main takeaway. Like, if you love something or you find things you love, stick with them. Don't really like try not to take in like the boxes people try to put you into in terms of what you should be doing, what you're supposed to be doing in terms of job career path. If like you're really passionate about something, you can figure out a way to make that what you want it to be. Um, and that's not just for STEM. That's like for anything. Like if you want to be an artist and people are telling you, oh, art's not going to make you money. Like you can always find a way to set yourself up to be in the position you want to be in. It just takes a little more creativity if you're going to build your own path. But actually, I think it's a little more fun that way. Get to actually make some more decisions. Being going to MIT, it's as much as it's a great time, you do meet people who like their first time thinking about what they want to do with their life comes when they're graduating. Um, from just because you have this, certain set of people who had this plan mapped out forever. And like, and sometimes I've wanted to go to MIT forever, but I've had to like make decisions to kind of set myself up there where people were just like, I did well in school. I went to this place, I did this. And then I like got to MIT. I'm like, for the first time, like, I actually don't know what I want to do with my life. And so I would just say like, really think about who you are as a person, try and find that first. As the earlier, the better, but it's okay if it's like, you're later and still trying to figure it out. And then once you find that thing, like, really go at it. It doesn't matter what resources you have access to. Like make the best of what you have. And yeah, I think that's the only thing I can say there.
I think that's great advice. And then just because you are working in, I guess I could call it the field of the future with AI, could you give a little bit of, I guess, your own ideas of where you think either your career in AI could take you? And then that's the first one. And then the second one would be, where do you see computer vision going? Like if it was possible, just like your wildest imagines, where did you think it could go?
Yeah. Okay. So first one, my career in AI could take me. I don't know. Like in terms of answering that question, it's weird because I'm in this space right now where like I wake up every day during the week and get to work on the coolest problems. So, like I feel like it's taken me to where I wanted to go. In terms of career plans for the future, right now my career plans are like keep doing what I love until maybe for some reason I don't love it, then switch to doing something else. But like this is so cool every day to be able to work on these hard problems. It's like changing all the time. And so, I think it could take me to building, tools in the future that people use that, people love to work with that make people's lives easier. And so I guess that's how the original reason I got into technology is like, you can build these things that, 10x people's productivity or like make people's lives easier or benefit, people as a whole. And so I guess for me, that's kind of where my focus is from a tech side of things. And then computer vision in the future, I mean, there's so much there. I think one thing is the generalization problem we talked about earlier. I think this is a big thing people have to work on. I actually don't know if it's fully solvable, if it's possible. Maybe it's not solvable, but I think it's the main thing we face right now. Even with things like ChatGPT, you'll notice there's cracks. There's things where like one thing I think has only been fixed or they only updated really recently was ChatGPT before the last couple months couldn't ask ChatGPT to add like two 10-digit numbers. Like once you learn addition, it's going to take you a while, but I can give you any length, like number of digit numbers and you can add them together. ChatGPT gets very confused if you make the digits like too many. It doesn't really understand what's going on. You can see it doesn't really understand what it needs to do addition. And there's a lot of reasons for that I won't like really get into in detail, but so I think generalization there is one big thing. Like we're training on all this data and the way people, I guess, are going to generalize right now or trying to is, hey, if we train on everything, then like we should capture all of the stuff. But there are still cases that you're not going to capture that aren't represented, on the internet. One good example in computer vision is if people are noticing if you take a picture of something on the internet, certain images are always taken in the same orientation. So if you think about like a cup, like a mug or a cup or something, typically it's taken from the side on because it has some like logo or text on the side. It's never going to be like top down looking into like the mug often. there's always going to be there's like patterns that you see because the images on the internet are built for like, people buying something or these types of things. And so the AI model, actually, you have to do tricks to get it to generalize farther than that. And so I think generalization's one, and then embodied intelligence is the other one. And I think a lot of people are working on that at MIT. What I mean by that is like actually putting these things into robots and things that have to operate in the real world. It's not easy enough, but it's, difficult problem. But to take something in a computer and say, is this a cat or a dog? Can you describe this for me? But when you have to actually make decisions based on that information, when you have to look at an image and, you take a video in as input of, your robot driving through the living room, and now you have to make a decision of like how to pick up that cup that's on the table that's like slightly tilted or whatever. And, now you have to make decisions based on that information. I think that's the next step that, makes the problem much more difficult when you're combining like both the computer vision understanding with the like action planning stuff of robotics. And so I think we'll see a lot more of that soon. There's a lot of people working on really cool stuff there. Self-driving cars is like a perfect example of that problem in action. But yeah.
Definitely. Wow. Well, this has been an amazing conversation. It's so cool to speak with somebody like yourself who's already kind of like, thinking of and building the future, like I mentioned before. So it's been really wonderful to talk to you. Thank you so much for your time.
Yeah, thank you.
Thanks for stepping into the lab. I hope you enjoyed another deep dive into the fascinating world of STEM. For more insights, be sure to subscribe. And if you want to be a closer part of the community, follow me on Instagram and TikTok at Camerons_lab. See you next time.